Did you know there may be a planet where it literally rains diamonds? Forget everything you know about rain. On Earth, rain falls as water. Somewhere else in our universe, scientists believe the skies could produce something completely different. Carbon compressed under unimaginable pressure until it forms one of the most valuable materials known to us. But here's the strange part. We aren't talking about a planet made entirely of diamonds. We're talking about a world where conditions deep inside the atmosphere may actually turn carbon into diamond crystals, and then send those crystals falling deeper into the planet. And if you're wondering how scientists could possibly know something like this about a planet hundreds of millions of kilometers away, that's where this story gets really interesting. Before we uncover how diamond rain could happen, take a second to subscribe to Beyond Maps and share this video with someone who loves discovering things they never knew existed. Now, let's travel far beyond Earth. The planet we're talking about is Neptune. From a distance, Neptune looks like a beautiful blue sphere floating quietly in the darkness. But beneath those blue clouds is an environment almost impossible to imagine. The temperatures and pressures become so extreme that ordinary materials begin behaving in extraordinary ways.
Neptune is an ice giant, and much of its interior is thought to contain hydrogen, helium, water, ammonia, and methane-rich material. And methane is the key to our strange story. Methane contains carbon. Under ordinary conditions, that carbon remains locked inside a simple molecule. But deep inside Neptune, the pressure becomes millions of times greater than the pressure we experience at Earth's surface. At those depths, researchers have proposed that methane can break apart. The hydrogen can move away, while the carbon is subjected to enormous pressure. And that's where something extraordinary may happen. The carbon can be transformed into diamond. Imagine tiny carbon crystals forming in an atmosphere thousands of kilometers beneath the visible clouds. At first, they could be microscopic, but as they descend into deeper and hotter layers, the pressure continues to increase. The diamonds become denser than the surrounding material, so they keep falling. Not through an Earth-like sky, but through a gigantic ocean of super-compressed planetary material. And this is where the phrase diamond rain comes from. But there's an even stranger question. Could this really happen, or is diamond rain just a fascinating scientific theory? To answer that, scientists had to recreate a tiny piece of Neptune right here on Earth. And what happened inside those experiments would make the idea of diamond rain much more than science fiction.
The idea of diamonds falling inside Neptune sounds almost unbelievable. So scientists faced a simple question. Could they actually reproduce the conditions that might create them? Obviously, nobody could build a machine capable of recreating an entire planet. Instead, researchers needed to create something much smaller, but under extreme conditions. They used powerful lasers and specialized laboratory equipment to compress materials to pressures and temperatures similar to those believed to exist deep inside ice giants like Neptune and Uranus. And the material they focused on was especially important: hydrocarbons. These compounds contain hydrogen and carbon, the same basic ingredients that make the diamond rain hypothesis possible. In one famous line of experiments, researchers used a material called polystyrene, which contains carbon and hydrogen, as a laboratory stand-in for some of the carbon-rich material inside these planets. Then came the extraordinary part. The researchers hit tiny samples with incredibly powerful laser pulses. For an instant, the material was subjected to pressures and temperatures that are almost impossible to reproduce under normal conditions. The molecules began breaking apart. Hydrogen moved away, and carbon atoms were pushed together under enormous pressure. Then, something unexpected appeared. Tiny diamond structures began forming. The diamonds were incredibly small, far too small to use in a jewelry store. But that wasn't the point. The experiment was testing whether the basic physics behind diamond formation could actually work under conditions similar to those inside an ice giant. and the results suggested that it could. But there was still a major problem. Scientists weren't simply trying to prove that diamonds could form. They wanted to understand what happens after they form. Because inside Neptune, a diamond wouldn't simply appear and float around. It would be extremely dense compared with the surrounding material. So once the crystals formed, gravity would pull them downward. Imagine a microscopic diamond falling through an ocean that is thousands of kilometers deep.
But this wouldn't be anything like a snowflake falling through Earth's atmosphere. As the diamond travels deeper, the pressure increases, the temperature increases, and the material surrounding it becomes stranger and stranger. Eventually, the diamond could descend into regions so extreme that it may no longer behave like the familiar gemstone sitting inside a jewelry box. Scientists think this process could release energy as the diamonds sink, and that may help explain something else about Neptune. Its interior is incredibly hot. Neptune receives very little energy from the distant sun compared with Earth. Yet the planet radiates significantly more energy into space than it receives from sunlight. That means Neptune has a powerful internal heat source. Diamond formation and sinking could potentially contribute to the way energy moves through its interior. But there's an important distinction. Scientists have not watched diamonds falling through Neptune with their own eyes. No spacecraft has drilled into the planet. No camera has recorded diamond rain. What we have instead is a combination of planetary physics, computer models, observations of Neptune and Uranus, and laboratory experiments designed to recreate their extreme interiors. And that's what makes this story so fascinating. Something happening hundreds of millions of kilometers away can be investigated inside a laboratory on Earth. But the deeper scientists look into these planets, the stranger the story becomes. Because beneath the clouds of Neptune may not simply be an ocean of hot material. There could be an environment where water itself behaves in a way that sounds almost impossible. And that discovery takes us even deeper into the planet.
The possibility of diamond rain is already difficult to imagine. But the deeper scientists look into Neptune, the stranger this planet becomes. Because the diamonds may not be the only thing behaving differently down there. The water itself may enter a state that doesn't naturally exist on Earth's surface. Remember, Neptune is not a solid planet with a surface you could stand on. Its atmosphere gradually becomes denser and hotter as you travel downward, eventually merging into a deep, extremely compressed interior rich in water, ammonia, and methane. NASA, science plus one. And under those enormous pressures, ordinary descriptions of water begin to break down. Scientists have proposed that parts of the interior of Neptune and Uranus contain superionic water. This sounds almost like science fiction, but the idea is based on physics.
In this state, the oxygen atoms can form a relatively stable structure, while hydrogen ions move through it. In other words, the water isn't behaving like the liquid we drink on Earth. It is behaving more like a strange hybrid between a solid and a liquid. And there's another reason scientists care about this. This unusual material could help explain how these planets generate their unusual magnetic fields. The deeper you go, the more extreme the environment becomes. Pressure climbs, temperature rises, chemistry changes, and materials that seem familiar from Earth can behave in ways that are almost impossible to reproduce naturally on our planet. But here's something even more fascinating. The diamond rain may actually be connected to this strange interior.
As carbon separates from methane and forms diamond, those dense crystals could sink through the surrounding material. That movement could transport energy downward and potentially contribute to the way heat moves through the planet. Scientists have investigated these ideas using laboratory experiments and simulations designed to reproduce the extreme conditions expected inside ice giants. Nature plus one. But we need to be careful with the word confirmed. Nobody has directly observed diamonds falling inside Neptune. There has never been a spacecraft sitting inside the planet watching the process happen. Instead, scientists are piecing together evidence from experiments, calculations, and what we know about Neptune's composition. And that distinction matters, because the phrase diamond rain sounds like a confirmed weather forecast. It isn't. It is a scientific model, supported by experimental evidence that carbon can form diamonds under conditions relevant to ice giant interiors.
And that makes the real story even more interesting. We don't need to invent an alien world. The real Neptune is already bizarre enough. It is more than 30 times farther from the Sun than Earth, yet it has an enormous internal heat source and some of the fastest winds known in the solar system. NASA reports winds reaching roughly 2,000 kilometers per hour. NASA Science +1. And beneath those violent clouds could be an environment where carbon turns into diamonds, water becomes superionic, and unimaginable pressures reshape matter itself. But there is still one major question. If diamonds really are forming deep inside Neptune, what happens to them after they sink? Do they remain diamonds? Do they melt? Do they eventually reach a deeper region of the planet? And could this strange process help explain why Neptune produces so much internal heat? To answer that, we have to travel even deeper. And what scientists think may be happening there is stranger than the diamond rain itself.
For years, the simplest version of the story sounded almost perfect. Carbon separates from the surrounding material. It becomes diamond. The diamond becomes heavier, and gravity pulls it deeper and deeper toward Neptune's core. But there is a problem with that story. What if the diamond doesn't survive the entire journey? Recent research is giving scientists a much more complicated possibility. Deep inside Neptune, the falling carbon would eventually encounter an environment containing enormous amounts of water, oxygen, hydrogen, and other elements. And at the temperatures and pressures found there, diamonds may not simply remain chemically unchanged forever. A 2026 study proposed something particularly strange. The carbon from the falling diamonds could potentially react with material near the boundary between Neptune's deep mantle and its core.
Instead of forming a permanent mountain of diamonds around the core, some of that carbon could be transformed into unusual carbon-rich compounds. Scientists studying these conditions have even proposed exotic superionic carbonic acid phases. That sounds like something from a science fiction movie. But remember what we've already discovered. Inside these planets, ordinary rules of matter begin to change. Water can enter a superionic state. Hydrogen can move through a solid-like oxygen structure. Carbon can separate from hydrogen and form diamond. And now scientists are investigating whether that carbon can be chemically transformed again much deeper down. So perhaps the diamond rain isn't actually the final stage. It could be part of a planetary recycling system. Carbon begins high in the atmosphere as methane. Extreme pressure and temperature break those molecules apart. The carbon forms diamond.
Gravity pulls the diamond downward. And eventually, under even more extreme conditions, that carbon may interact with water and minerals and become something completely different. In other words, Neptune may be recycling its own elements deep inside the planet. And that could matter for something much bigger than diamonds. It could help scientists understand how Neptune's interior moves energy. It could also provide clues about why Neptune and Uranus have such unusual magnetic fields. The magnetic fields of these planets are unlike Earth's simple, relatively centered magnetic field. Their magnetic structures are strongly tilted and offset from the planet's centers. Scientists have long suspected that unusual electrically conducting layers deep inside the planets may play a role. Superionic water is one possible contributor because it can conduct electricity under extreme conditions. Nature plus one. And this is where the story becomes truly fascinating. The diamonds, the strange water, the extreme pressure, the magnetic field. They may not be separate mysteries. They could all be pieces of the same enormous machine operating beneath Neptune's blue atmosphere. But there is still one thing we haven't answered. How can scientists possibly know what is happening thousands of kilometers beneath a planet that no spacecraft has ever entered? The answer is one of the most impressive parts of this entire story. They don't have to travel to Neptune. They bring Neptune to Earth. In laboratories, scientists use powerful lasers, X-rays, and high-pressure experiments to recreate tiny pieces of the environment expected inside these distant worlds. In one experiment, researchers compressed hydrocarbon material to around 150 gigapascals and temperatures around 5,000 Kelvin, conditions comparable to those expected deep inside Neptune and Uranus, and observed evidence of diamond formation. Nature. They have even experimentally produced superionic ice under extreme conditions using powerful lasers and X-ray measurements. Lawrence Livermore National Laboratory. So when scientists say Neptune may have diamond rain, they're not simply imagining a fantasy. They're testing the physics. But the deeper they investigate, the less Neptune looks like the simple blue planet we see from space. And there is still one final mystery. If diamonds are forming, sinking, and potentially transforming deep inside Neptune, could there be an enormous amount of them down there? And if so, what would happen if humanity could somehow reach them? That is where the story gets even more extraordinary.
So, does it really rain diamonds on Neptune? The answer is more complicated than the headline. Scientists have not watched diamonds falling inside Neptune. No spacecraft has entered its interior. No camera has recorded a diamond falling through its atmosphere. What scientists have done is something different. They have recreated pieces of Neptune's extreme environment here on Earth. And experiments have shown that carbon-rich materials can produce diamonds under pressures and temperatures similar to those expected deep inside ice giants. That makes diamond rain a scientifically plausible process, not a fantasy. But there is still uncertainty about exactly how much diamond forms, how large those diamonds become, how far they travel, and what ultimately happens to them. And that uncertainty is actually what makes Neptune so fascinating.
Think about what we've uncovered. A planet more than 4 times wider than Earth, with winds reaching incredible speeds, an atmosphere containing methane, an interior where pressure becomes millions of times greater than what we experience at Earth's surface, water that may exist in an exotic superionic state, and carbon that may be transformed into diamonds thousands of kilometers beneath the clouds. And then those diamonds may begin a journey downward, into a world where even the word solid starts to lose its familiar meaning. This isn't a fantasy planet. It's a real world in our own solar system. And yet, we've only visited it once.
In 1989, NASA's Voyager 2 became the first and only spacecraft to fly past Neptune. It transformed our understanding of the distant planet. We discovered enormous storms, powerful winds, a complex ring system, and a world far more dynamic than scientists had expected. But Voyager 2 only passed by. It didn't enter Neptune's atmosphere. It didn't drill into the planet. It couldn't tell us exactly what is happening thousands of kilometers beneath those blue clouds. So in many ways, Neptune remains a mystery. And perhaps that's the most exciting part. Because every time scientists develop a better experiment, a better computer model, or a better telescope, they discover another layer of complexity.
And there's a lesson hidden inside this strange story. When we hear the words, "It rains diamonds on Neptune," it sounds like an unbelievable fact. But behind that sentence is a much bigger scientific story. It's a story about how matter changes under extreme pressure, how carbon can move from one form to another,
how water can behave in ways we never experience on Earth, and how scientists can investigate a world they cannot physically reach by recreating its conditions in a laboratory. That's what makes science so powerful. Sometimes, you don't have to travel somewhere to discover what might be happening there.
So somewhere far beyond Earth, beneath the blue clouds of Neptune, there may be tiny crystals of diamond falling through a world unlike anything we've ever experienced. They may sink deeper. They may transform. They may contribute to the strange physics of the planet's interior. Or perhaps future experiments will reveal that the process is even more complicated than we currently understand. We don't know every detail yet, and that's okay, because sometimes the most fascinating discoveries begin with a question, not an answer.
Imagine standing on Earth, looking up at the night sky, and realizing that somewhere in that darkness is a planet where the forces of nature may be creating diamonds, not inside a jewelry store, not inside a laboratory, but deep inside an alien world. A world that looks like a simple blue dot from millions of kilometers away, but may contain an environment more extraordinary than anything on Earth's surface. Neptune reminds us that our universe is far stranger than it looks. And the next time you see a diamond, remember, somewhere in the darkness, nature may be making them in a completely different way. If this story surprised you, subscribe to Beyond Maps, because this is what we do. We go beyond the familiar, beyond the headlines, and beyond the places you've already heard about to uncover the strange, extraordinary, and little-known realities of our world and the universe around us. And if you know someone who would never believe that diamonds could fall from the sky on another planet, share this documentary with them, because there is still so much out there that most of us have never heard of. This is Beyond Maps, and there's always more beyond the map.